All right, hello everyone, this is Mr. Courage. I'm going to go over Chapter 2, Practice Test Number 2. The first problem says use the numerical derivative function. Well, that is a feature of your calculator. If you hit Math 8, you can set up your calculator, and your calculator will go ahead and do that work for you. Let's close all the parentheses, 4, and there you go. Your calculator went ahead and took the derivative of that function at that value. And there you have your answer. So you can do the same things for the next two. On the next one, we have a function, and we're going to take the first and second derivatives and then make a table. Well, you can have your calculator, you can put all three of them right in here. 48x minus 8x squared, 48 minus 16x, and negative 16. And you can go to the second table feature, and there's a table. If your table is not working out right, I would just reset your calculator. Down here where it says memory, I'd hit second memory, and I would go ahead and just check the memory and reset it by pressing number 7. All right, on number 3, we're going to do the quotient rule. Low d high minus high d low all over low squared. Simplify the top down as far as we can. Bottom never really simplifies. On number 4, given this function, find the rate of change when x is equal to 4. Well, that's instantaneous rate of change. We only have 1 point. Since we only have 1 point, we take the derivative and plug in that point. But on the second one, that rate of change over this, we have an interval here. We have 2 separate points. We have the first point and the second point. So since we have 2 points, we can do the slope formula. This is not a point, this is an interval. If I were to graph it, it would go from -2 to 3. And there's a function, and I'm finding the slope between those 2 points. On number 5, it kind of walks you through our steps. We have a function, plug in 4 to the function, get out 16. Next one says find the derivative. Well, do the derivative. And the last step says plug in 4 into your derivative. And to find the tangent, I just did point slope form here, y minus y1, and that comes from right here. Right here is your point, 416, x1, y1. Y minus 16, use the slope, did the point, and I went ahead and put this in point slope form right there, or slope intercept form. And the last one, tangent line here. Take the derivative, plug in 1, this becomes my slope. Now I went, on this problem, I went y equals mx plus b, and I found the b value that way. On this one up here, I did point slope. So there's 2 options. You can use this formula, or we could do point slope. They both get you to the same spot. I think this one's a little bit easier. If you know a point and a slope, you can use that, but you're welcome to do it this way. All right, on page 2, number 7, find the normal line. Well, we've been doing tangents, and tangents are points that are lines that are tangent. A normal line is just a line that is an opposite reciprocal. So if the tangent is -4, the normal is 1/4. It's just a perpendicular line at the tangent. Number 8 is a related rates problem. We have an area and a radius, and they're both changing with respect to time. So the work I did here was I took this and I did ddt to both sides. ddt to both sides got me here, plugged in everything I needed to know. Thankfully, what I was solving for was here, and all I had to do was that computation and got my answer. Number 9 is the difference quotient. We know the power rule, so we know the answer is -4x. But this problem is about, do you remember how to do it the long way? Set it up, get to the end, plug in 0 for h, and you should get the same answer. On number 10, it's a simple problem. All you have to do is take the derivative twice. All you have to do is take the derivative once, take the derivative again, derivative of a derivative. What do we have here? Same thing, derivative twice. Take the derivative once, then we go ahead and take the derivative. Whoops, I think this was just supposed to be a single derivative problem. Make sure we correct that. You didn't need to take the derivative twice, just take the derivative once. On the next one, find the slope at this. So we have to find the derivative and plug in this point. Well, this is an implicit function right here. So we find this with our dy, we solve dy dx here, and then we plug it in. So it's the exact same problem that we've been doing over and over and over again. However, on this one, we have to solve for the dy dx. All right, number 13, where is this function continuous? It's continuous everywhere. There's no holes or jumps or asymptotes. But it's not differentiable here. You can't find a derivative. There's no derivative at a sharp corner or a cusp. There's no derivative there. On the bottom one, we just take the derivative, and be careful right here on this part here. It is left d right plus right d left. Have to do the power. You can do this normal. Here you have to do the product rule. And watch what I did here. I'm subtracting all of that. So this is going to be minus this and minus that right there at the end. Because it's lefty right minus righty left. Subtract all of that. All right, on number 15, I just did some basic derivatives. Have to use the chain rule. Took the derivative, chain rule. Same thing here. I went ahead and I got it into a calculus-friendly form. Did the derivative, chain rule. On this one, pi is just another number. Again, don't forget the chain rule. On this down here, this is implicit. We're going to have a y built in here, and so we have a derivative that's in here, 2y, then the dy, and don't forget left d right plus right d left right here. This is my left d right plus right d left. And we solve for dy dx. Number 16, they were supposed to be in feet, all of them. We just have a volume formula, and this time we differentiated it. But this time the thing we need is over here, meaning we have to take this and divide all of this over here. Now make sure when you use your calculator, you're dividing by all of that, not just the 4 and the pi. You're dividing by a 4, a pi, and a 7. Let me write that out on my calculator. How you're going to want to type this in is 2.1 divided by a 4, a pi, and a 7 squared is 49. So you want to divide by all of that. A lot of people just do this on their calculator, and then your calculator only divides by the 4. Then it turns around and multiplies by it. Make sure you're doing the top one. 17, take the derivative, plug in 16. Make sure you know these derivative rules here. They're on the front page of your book. What do you do in this situation? In this situation, they were 3-part plans. I'll do this one here. It's 3x, a natural log, and then the chain rule. Same thing here. It's 1 over x, 1 over ln of 3, and then the chain rule. 3-part problems. All right, we have a graph here, and we're trying to find h prime of 2. Well, all you have to do here is take the derivative, plug in 2. What do you have to do here? All you have to do here is plug 3.5 into the function. Now, what about the maximum? Well, if we want to get the maximum, let's go ahead and see what this picture looks like. Let me graph this real quick. Negative x to the 4th plus 4x cubed plus 10. My window 0 to 5, 0 to 40. And there's a picture of my graph. If I want to get this highest point, I can just use the trace button, and we can just estimate. There's the highest point. It's at about 3 and 37. It will be enough on this test to just use a trace button. Now, there are some fancier buttons in the calc up here. If you know how to use those, you're welcome to. But for this test, using the trace button will be enough. D, find and interpret zeros. Zeros are where the graph hits the x-axis, where the output 0. So about right there, the output 0. That's where it hits the ground. And the last one, E. When is the velocity negative? When is it going down? After 3 seconds. These derivatives are all negatives going down that way. All right, on the last page, there's your proof for sine of inverse sine. You start by taking the sine of both sides. Then you take the derivative of both sides. Then you divide over the cosine. And then you replace cosine y by solving this equation over here. Cosine squared plus sine squared is equal to 1. You can turn that into the square root of 1 minus sine squared, which is right there. And then you just use this logic here to say I'm going to sub out the sine of y and put x in its place. All right, 21. 21 has a classic problem about a ladder. The ladder is moving down in the y direction, and it's moving that way in the x directions. Those two rates are related. I'm told what dy is. I'm not told what dx is, but I am told that at a certain point in time, this is 8. And if I use my Pythagorean theorem, and whoops, this is 17 and this is 8, I can figure out that y is 15 with the Pythagorean theorem. 8 squared plus y squared equals 15. Differentiate with respect to time, plug in what you know, solve for what you don't. And on the last one, the tangent through this point, well, use point slope. I know the x, I know the y. Take the derivative, plug in your x and y, you'll figure out the slope. And there's my formula. It's y minus y1, m x minus x1. All right, hope this helps. The answers are there. If you have any questions, please see me in class, and good luck on your quiz. Test.